Here we have a three-phase motor demonstrator set up where we're using an old Delco-Remy alternator as a three-phase motor, and we have a piece of reflective tape on the shiv, another one on the cooling fan, and we're freezing its apparent motion using a stroboscope. We can dial up the frequency on the stroboscope to whatever speed we want, and it's going to make it appear as though this is standing still. If I take this frequency and adjust it down to a lesser value, what I find is that I see that piece of tape apparently moving around. If I speed up my stroboscope frequency, I'll focus on this as I speed it up. Now it looks like it's standing still. If I go too fast, if I crank this up higher than it should be, then it looks like we're going backwards on this. What I'd like to demonstrate is that I can actually have different frequencies of strobe light flashing that'll also make it look like this tape is standing still. For example, if I flash at half the frequency, so instead of flashing at 1800 RPM, it'll turn down to about 900. As we get close, we'll see over here, we'll start to lock in one more time. There we go. It looks as though the piece of tape is almost standing still again, and that's because our frequency is down around 900 per minute. So what's happening is we're actually flashing once every other revolution. So we have 2 revolutions for one flash of the strobe light, and it still looks like the tape is standing still. We can do a ratio of 1/3 as well. We can turn that down to about 600 RPM. And we can lock in one more time. Down and down we go. Keep going, we keep going. So now we're flashing once every 3 revolutions of the motor. And it looks like we're just about standing still. And that's around 600 RPM. So you have to be careful when you're using a stroboscope that you're not flashing the light at some factor of the motor's speed, but rather you're flashing it at the motor's speed. So here's how we tell. If we got it locked in like this and we're wondering, well gee, is this the right speed or are we flashing too slow? Are we catching every other or every other rotation? You just increase the strobe speed and see if you can get it to lock in another time with it standing still in one place. If so, you're going too slow. I'll try it again. Faster, 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 faster. And here we have our true speed at about close to 1800 RPM. Now if I go faster than this flash rate with the strobe light, I will not be able to lock it into a single position again. What I'll do is I'll be flashing at a multiple of the speed, and if anything, I'll see multiple pieces of tape, not just the one lineup that we see right here. So here I go with a faster speed. Faster, faster, faster with my strobe light. So right here, I see what looks like 2 sets of tape, and that's because I'm flashing at twice the speed that the motor is actually spinning at. If I go faster yet, I should be able to lock in and see 3 pieces of tape. There we go. It appears that I have 3 pieces of tape now because I'm actually flashing 3 times per rotation. So looking over here, we're at 5500 RPM. In reality, this is going closer to 1800 RPM, but I'm flashing 3 times per rotation, so it looks like I have 3 pieces of tape. I can go faster and faster, and I will never lock into a single piece of tape anymore. It'll always be some multiple, some integer multiple. There's 4 times the speed. And here's 5 times the speed. Going down, I'm going to slow down 4 times, 3 times, 2 times, and then this is flashing at the proper speed. This is what the motor is actually turning right here, and that is close to 1800 RPM. So a simple demonstration of a stroboscope.